Hello, guys. Let's get the show on the road. This will be a quick review of what we did last Friday, and I'll introduce a couple new concepts, the intersection and union in this video as well. So to begin with, what we started last Friday was Unit 3 on sets, and a set is simply just a collection of things. There's not a whole lot more to it than that. We just think of a set being just some things that we have in a little group. Those things that we're referring to, I will call elements. So the elements they just happen to be the things in the sets. And a very particular type of set is a subset. And this is a set that is contained in another one. So this is kind of like the small set compared to a bigger set that contains it. And then we have a couple of symbols. So we have the symbol for an element is this funny looking E, and this means is an element of. This is how you would read that out loud. And then this, which kind of looks like a less than or equal to sign, but it's curved, means is a subset of. So let's look at this example here. Here's an example of a set. It has the number 2, the color red, an arrow, the fruit and apple, and person. So this set has 5 elements in it. When we give sets names, we normally give them capital letters. So either like a capital A, maybe a capital S. And for instance, 2 is one of the elements in here. So I can write 2 is an element of S. That's exactly what this means. Likewise, I could find a subset here. So I could take the arrow and an apple, and this is a subset of S. This is a set, but everything in this set happens to be contained in the big set. So hence it is a subset. Let's look at a nice example just to remind ourselves what we're looking at. So here I have 3 examples of sets. We have set R, S, and T. R contains all 5 vowels, S contains the first 3 vowels, and T contains the last 3 vowels. So for instance, we could ask, is A an element of R? And A is one of those elements. So this is true. We could ask, is S an element of R? And if we look at R has 5 elements, A, E, I, O, and U, and S is not any one of those 5 elements. So this is actually false. They're very, very specifically, this means is an element of, and S is none of the 5 elements in there. So S is not an element of R. We could ask, is E an element of S? And we can see, yes, there is an E in the set S. So this is in fact true. This symbol means is a subset of. So is S a subset of T? And we can look at the elements in S and we can ask, oh, is this set of things also going to be in T? And the answer is no. This is going to be false. Again, when we look at S has the elements A, E, and I in it, but T doesn't have all those in it. So for instance, A is in S, but A isn't in T. So this is not a subset of T. We could ask, is R an element of O? Okay. This is going to be false. Specifically because this is backwards. If we wrote O is an element of R, that is in fact true, but R is not an element of O. R is inside of O. Sorry. O is inside of R. R is not inside of O. So the order does matter here. We could ask, is A subset of R? And we can see that A is in fact in R, but A is an element of R, and it is not a subset. This is false. In order to be a subset, you have to be a set. So A by itself is not a set. It is just a letter. It is an element. So A is an element of R would be correct. A is not a subset of R. We could ask, is S a subset of R? And we look at S, which has A, E, and I in it. And then we look at R, which also has A, E, and I, and a few extras. So this is going to be true. Every element in S is in R. So we are good to go. And then we could ask, is E an element of T? And we look in here and we look at all the elements of T. T has 3 elements and E is not one of them. So this is false. Okay, let's keep going. Is T a subset of S? So is everything in T inside of S? And this is not true because I can find elements in T that are not in S. So this is not a subset. So up here we had S as a subset of T, and down here we have T as a subset of S. So neither of these are true. It doesn't matter what order we put it in because these sets are not contained in one another. And then lastly, is R a subset of T? So that's asking, is everything in R also in T? And this is not true because R has some things, for instance, an A and an E, that aren't in T. So this is also false. If we were to write this in reverse, T is a subset of R, that works, but R is not a subset of T. So again, the order matters. Kind of think of subsets as being less than or equal to, and R has more things in it than T. So R is not going to be a subset. Just to continue practicing, let's think about things for just a little bit. So here I have, let's list all the elements of this set. And that's pretty easy. All the elements are just going to be 1, 2, and 3. There's nothing more to it than that. But I could also ask you to list some subsets. So be prepared on the quiz on Wednesday for a question like this. So for instance, I could list all of the subsets, and I'm going to do this in order of size. So for instance, I could list all the subsets with two elements. Let's try those ones first. Well, I can have a 1 and a 2. This is a subset of the set 1, 1, 2, 3. This is a subset, and so is this. So these are all subsets of this one because every element in each of these is also up here. I could also look at the 1 element subsets. So for instance, if I just had a 1, if I just had a 2, or if I just had a 3, 1 is in here. So this set is in fact a subset. 2 is in here. So this set is in fact a subset. I could even find a 3 element subset. And this is going to be a little bit strange. But if we look at all of these numbers, every single one of these numbers is up here. So the element 1 is in there, the element 2 is in there, the element 3 is in there. So this is a subset of this. And again, we think of a subset as sort of being less than or equal to. Well, the or equal to part is just fine. So a set will be a subset of itself. And it's going to be a little bit weird. And then there is, in fact, one more subset here. We have our 0 element set. And then the symbol that we use is this. There's also another way to write this. I can just write the empty brackets around. So this set is also a subset. And this takes a little bit of explaining, and I might do this on Wednesday. But one thing to note is that the empty set is a subset of every set. Okay, so we've listed all the subsets here. And then we could also list some sets that this is going to be a subset of. So what I want to do is find a set where this is contained in another set. So for instance, I could write 1, 2, 3, 4. This is a subset of the second one. This is also a subset of 1, 2, 3, red, blue. Okay. That works. This is also a subset of itself. So we could come up with all sorts of sets. We could work all day and come up with loads and loads of sets. There are infinitely many to choose from, where this is a subset of that. So we can find subsets of this, or we could treat this as the subset and then find the bigger sets. So again, be prepared for this on Wednesday. So the final thing for today is to look at intersections and unions. So the intersection of sets A and B, this is taking two pre-existing sets and making a new one out of it. The intersection uses this funny symbol. It looks like an upside down sort of curve, kind of like an upside down U. And it is a set containing all the elements that are both in A and B. So the word "and" here is very specific. So for instance, if I look at the set 1, 2, 3 and the set 3, 4, 5, the intersection is going to be all the things that are in both of these. So is 1 in both of these sets? No, it's not. Is 2 in both of these sets? No, it's not. Is 3 in both of these sets? Yes, it is. Is 4 in both these sets? Is 5 in both these sets? No. The intersection is just 3. So when we're talking about intersection, what we're really doing is we're looking at the overlap between two sets. It's everything that is in both A and in B at the same time. So the intersection of two sets is where they overlap. If we think about the intersection of two roads, it's where the two roads meet. If these are my roads, they meet on the 3. So intersection is overlap, or we could do kind of the opposite of intersection and take unions. The union of two sets, A and B, and the symbol for this is a more of a U shape. It doesn't have the little tail hanging off, but it's just that curve. So the union of two sets is going to be another set that contains all the elements in A or in B. Just all the elements. So for instance, if I take the union of 1, 2, 3, and 4, 3, 4, 5, the union is going to contain 1 and 2 and 3 and 3 and 4 and 5. However, right now, there should be some of you screaming at me from class because guess what? Duplicates don't matter in a set. A set doesn't care if it has duplicates in it. So why even bother writing them down? So the union of two sets is just going to be taking everything in both sets and putting them all together into one big set. Again, union, you might think of union in terms of, say, like marriage, when, it's a holy union. And when two people are coming together, here, two sets are coming together to form one big set. So the word union means coming together and forming that big set. Whereas intersection is sort of the opposite of this, and we're looking for the things that are already in both sets. This is the overlap of both sets. There's a nice picture that we can draw for this. So if I have my set A and my set B, I can draw some circles. So everything in the circle represents A and everything in this circle represents B. So this whole thing is, for instance, the union. A union B. This little bit in here is where they overlap, and this is going to be A intersect B. So for instance, in my above examples, everything in A was 1, 2, and 3. and everything in B was 3, 4, and 5. So when I look at the intersection, oh, what's in both A and in B? Just the number 3. What's in the union of A and B? Well, 1, 2, 3, 4, and 5. The union is everything. The intersection is only the overlap. And let's do one final example just to work through a bunch of them. I have 3 sets here. So A is going to be the set 1, 3, 5, 7, and 9. B will be the set of even numbers, so 2, 4, 6, and 8. And then C is just the numbers 1 up through 5. 1, 2, 3, 4, and 5. So let's take some intersections and unions of these guys. So the intersection here is going to be what is in both A and in B. So intersection is overlap. When I look at A only has odd numbers. B only has even numbers. So when I start to write my list of things that's in both A and B, there's nothing in there. And this is in fact empty. And I can either write the empty set as these empty brackets, or if I want to be fancy, I can use the symbol. Let's take the union of A and B. If I take A and B and I take their union, I'm combining them into one big set. So what's going to be in that set? Well, for instance, 1, 3, 5, 7, and 9 are going to be in there, but so are 2, 4, 6, and 8. And again, it doesn't matter what order we write these in. A set does not care about order. A set cares about what's in there and what's not. And here we've got all the numbers 1 up through 9. All 1, 2, 3, 4, 5, 6, 7, 8, and 9. Cool. Let's look at A intersect C. So now we're looking at A, which is all these odd numbers, and C, which is the numbers 1, 1, 3, and 5. So the intersection is what's in both of these. So what is in both? 1, 3, and 5 is in both A and in C. A will not have 2 and 4 in it, and C doesn't have the 7 and 9. So this is our entire overlap. It's just the numbers 1, 3, and 5. A union C, on the other hand, will take everything in A and in C and combine them together. So for instance, if I'm taking all of the elements in A, and then all the elements in C, well, I've already written a 1 in there. I don't need to write it down twice. I've already written a 3 and a 5. I don't have my 2 and my 4 yet. So for instance, A union C would have the numbers 1, 3, 5, 7, 9, 2, and 4. And it doesn't matter what order we write them in. Sets don't care about order. Okay, so let's look at B intersect C and B union C. So now we're going to look at these bottom two. So we've got the even numbers and then the numbers 1 through 5. So the intersection is the overlap. It is what's in both of them. 2, for instance, is in both of these sets. 4 is in both of these sets. There's no 6 down here. There's no 8 down here. Likewise, there's no 1, 3, or 5. There's no odd numbers. So that's it. There's our complete list of all numbers that are in both B and in C. With the union, what's in B or C? Well, we can take all the elements in B and then throw in all the rest of the elements in C. So we have a 1. I already wrote a 2 down. I'm not going to worry about 2. We'll need a 3. Don't need to worry about 4 again, and 5. So we have all the elements in B and all the elements in C, not bothering to write down duplicates. Cool. So a couple more quick examples. So we'll just remember that C is the numbers 1 through 5. So for instance, when I'm looking at the intersection, if I take C and I intersect the empty set, what I'm asking is, what is the overlap of these two sets? What elements are both in C and the empty set? Well, C has the numbers 1, 2, 3, 4, and 5. The empty set doesn't have anything. So when I ask what's in both sets, oh, it's nothing. So in fact, C intersect the empty set is again just empty. There's nothing that's in both of them. And I can either write the empty set using the empty brackets, or I can use it writing the symbol. So I'm just going to write it like this for now. Excuse me. Or I can take the union. So this is taking the set C and I'm going to union it with the empty set. So what happens here? I'm going to take C union the empty set. I'm going to take everything in C and everything in the empty set, and I'm going to put it together. Well, if I take everything in C and I add nothing to it, I just have C. There's nothing more that I've added to it. So C has 1, 2, 3, 4, and 5. And then I am combining it with an empty set. So I'm adding nothing to it. So I just have the numbers 1, 2, 3, 4, and 5, which was C to begin with. So C union the empty set is just itself. And then we get into a funny situation. What happens if we take a set and intersect it with itself? So C has the numbers 1, 2, 3, 4, and 5. C has the numbers 1, 2, 3, 4, and 5. If I intersect them, I'm asking where they overlap. So what is in both C and in C? 1, 2, 3, 4, and 5, which is just C again. So I haven't cut out anything because everything that's in C is in C. So when I look for the overlap, it's everything, as in all of C. Likewise, if I take the union, C has the numbers 1, 2, 3, 4, and 5. C has the numbers 1, 2, 3, 4, and 5. So if I put all that in a big set together, that's also going to have the numbers 1, 2, 3, 4, and 5, which is just C again. So I haven't added anything new. This is still the same set. So this has been like a really brief introduction into taking some intersections and unions and reviewing what we did last Friday. For the quiz on Wednesday, be prepared for understanding what elements are and what subsets are, and being able to come up with some on your own. If I give you a set, you should know what the elements are, you should know what some of the subsets are, and you should know how to make a set so that that is a subset of something else. I'll see you guys on Wednesday, and thanks for watching.